Greetings and permutations. Welcome to Geekus Maximus. I'm Dave, your host. Today I'll be addressing hierarchical queries in SQL Server and compare two methods for retrieving this type of non-normalized data from a relational database. While a graph database would ideally be suited for this task, there are situations where an RDBMS is desirable or just unavoidable. One such example of use of hierarchical data is within an e-commerce site that has categories and subcategories all residing in a single table. Today I want to compare two types of queries that can query this kind of data from a relational database. One is the CTE, or Common Table Expression Query, which is pretty common and a lot of people probably already know about this. But the other method that hasn't been used too often and sometimes is more performant is the multiple join method. Anyway, let's get started. Okay, let's start with an example of what I'm talking about with a typical drop-down that is filled with categories and their subcategories and their subcategories and so forth. Okay, so I wrote an application here that will do such a test. So let's go. Let's see what we get here. Okay, here's a simple form, simple drop down. It's empty. I'm going to go ahead and load it. Click here, and the drop down should load. Okay, very good. And here's an example. We have primary categories whose parent ID is 0. Then you have another subcategory showing the primary category concatenated with a little arrow and the subcategory. And notice the colors get darker as you go down further deeper into the category subcategory chain tree. Here's another one. Colors darker. We're at 3 levels. Scroll down a little bit. And there we go. Here's some good ones here. Now we're 4 levels deep. We're even darker. 5 levels deep. 6 levels deep, and so forth. A client asked me to do this a while back for their data entry people that did not want to do cascading categories, subcategories with drop-downs. They wanted everything in one drop-down. Anyway, that's an example of what I'm talking about. I'll go ahead and close that. I'll leave the source code available on the website. And it's pretty simple, actually. Oops, wrong system here. Wrong one there. Let's try this one. Okay, here we go. It's basically an ADO.NET call that pulls the categories from a stored procedure. And what we'll talk about today is the different ways you can pull this data, of course. And that's it. I'll leave the source code for this on the links below. Okay, the next thing I want to do is create a table of categories and subcategories, and it's going to be a monster table, over 2 million records. So initially I created a database called TestDB, and there's no tables in there right now, so let's go ahead and create these tables. So I already created a query here. I'll go ahead and open it up. Now I can run this query. All it does is create the table with the primary key, etc. And the table just has the ID, name, parent ID, and whether the record is active or not. So let's click execute. And pick our proper database and table. Connect. And now it will run the query. I go back and refresh. Where'd it go? There it is. Refresh. And there's our nice little table. Now, if you want to do a create table really quickly, this is kind of an aside. You can always, if you have an existing table, you can always right click on that table and script table as create to and a file, send it to the clipboard or a new query. And that's the easiest way to do it. You can just let SSMS do it for you. And that's exactly what I did earlier. I had created this table using that. So that's just a little trick that makes things easier. Okay, well, we've created the table. Now we shall, in the next step, we shall populate this table with all of our categories and subcategories. Okay, we've created the table. Now it's time to populate it. So we want to run this little program I wrote just for this purpose. And this is a C# program, command line, console. And I'm defining 9 different levels. And for each level, there are 6 categories per level. Basically what this does is run this function recursively and increases the level for each and adds the each category to a list called cats up here. And then once it does that, it will and get through the all the recursion, completing that, and then we shall bulk insert all those cats into SQL Server. Now I'm using bulk insert by SQL Server for this. If you're wondering, get letter basically takes an integer and returns a letter code for that integer, depending on where we are, going A through, let's see, A through F. And then we call the bulk insert. Let's just run through this real quick. All this does is use SQL bulk copy, put the destination table, put a good enough timeout depending on how long it takes to run, and then you just simply write it to the server. That's a normal function here. This little side method, toDataTable, will take a list and convert it to a data table. I lifted this off a website and never looked back because this is probably the best little function I've seen on doing so. Okay, with that said, let's go ahead and create our categories. So I went ahead and running the insertions. This should take about 10 seconds. Very good. So we're done. All 2 million records are in the database, and we will use these records to run queries on. Very simple. Don't try this at home, or you can try it at home. That's okay. And you can just kind of see what's going on as it creates categories. It just adds another letter to each one and then increments a letter and so forth. So you can see right off the bat, we'll look at this one. This ID 13 has a parent ID of 7. Let's see, there's 6 A's in there. Let's see, where's our parent ID here? 7. We got 6 A's there. Very good. Its parent is 6, of course, 5 A's. And you see what's going on there. Pretty self-explanatory. Okay, let's run some queries now. First, I want to start with a basic common table expression query. And we will go ahead and plop that in here. And I've left this little commented area. It's just another way of concatenating stuff, and depending on the version of SQL Server that you are running will depend on whether this function actually works. This is rather new. Let's go ahead and run this. So, and while this is running, with the common table expression, you usually start it with a with keyword, then your alias, and then you have this little brackety area here, and you have this root basically it's like a root select, and this is the basis or the cornerstone or foundation of your common table expression. You have to have this for doing hierarchical queries. I believe you have to have it for doing any CTE. Not sure about that. And then the actual query that's going to rerun itself, if you will, recursively run and give you your information back, and then you select from that alias, that table alias here, to get your data back. This particular query, I just ran it on all 2,015,538 rows, took about 45 seconds. And notice everything is where it should be. And notice if you look in here, you'll say, wait a minute, that's not ID 2. Well, this number here from this query is the ID of the very first, the most root level category, if you will, not of the last one here. There is a way to do this the other way. Anyway, you can see your parent ID for this is the parent ID of category A, which is 1. Category A, boom. Very good. So that took, like I said, 45 seconds. So let's run another query. But this time I want to use the equivalent with the multiple join method. And here we go. I'm going to go ahead and copy this. I'll explain this while it's running. Click that in here. Okay, let's execute that. And what you see, wow, this thing's running pretty fast. What you see is self joins, multiple self joins, n levels deep, n being 9 in this case, because I have 9 separate joins, so I can do up to 9 levels deep. Now, if you don't need that many levels, you can always shorten this. And if you need more, you can always lengthen it. The pattern is pretty much the same, just outer join, outer join, outer join, and so on and so forth. And to get the name out, to get the concatenated name, I used concat _ ws, which is nice because you just put your little concatenation character and then everything you want to concatenate together. And then it puts it all together nicely for you. So that one took 15 seconds. And the common table expression took 45 seconds. Very interesting. So in this case, the multi-join method wins. Okay, let's go on to the next example. I'll go ahead and grab another query here. Sometimes you want to start at a certain branch. So in this case, we will start with this branch, whatever that number is, and then get our data back out. I'll start another one. Click here. Go ahead and run this. And while we're waiting, I'll explain some of this. So we're looking for, if you want to include the parent in there, you want to put parent ID equals the branch ID, and as well as the ID equaling the branch ID. And if you don't, you can just comment this line out. Take this one here, and there you go. And this will exclude the parent. And it might look a little counterintuitive because we have the parent ID here and we have added the branch ID to get that parent because that parent is going to be of that particular ID. Now, basically, we set the branch ID to whatever that number is. So I'm going to go ahead and show you where that is. What's that number again? Copy. We'll go ahead and put that in. Run it. So it was category F. So we wanted everything from category F and up. And our results, notice you only see category F and everything under it, active or not. we'll discuss active categories. Okay, so let's go ahead and do the equivalent for the branch ID. And I'll go ahead and copy the next multi-join query. Gets a little weird here. Paste this in here. Now the difference between this one and the last one is we have to test if the branch ID is existing here. And so you have to check each joined alias ID to see if it's in there. And this is also a little tricky. So this is kind of tricky. That's a little tricky. And there's two ways to do this. If you want to include the branch, this branch, in the output, you just leave this in here, the A. Notice it goes from right to left. If you want to exclude it, just take the a.id out. I'll go ahead and run this and see how long this takes. And it looks like we're already taking a little longer. It's still, okay, 13 seconds. What was it over here? This was 10 seconds. Interesting. So a little less data. We're giving the SQL Query Optimizer a little run for its money. Interesting, I found that I get different results depending on what database version I am querying. So right now we are using SQL Express 2019. And my results are a little bit different. They used to be faster on the 2014, but hey, there you go. So once again, you see, you get the same results. Let me close this out here. Basically, you get the same results. Now, it's arranged in a different order, but it is a relational database, so you really determine the order of your queries. And you shouldn't depend on the order at which a record was inserted. Okay, moving along. Let's go to another query here. I'm going to run and we're going to look at a, let's go on CTE. Now we want to see which categories are active. And the catch here is if there is a subcategory that is active and its parent category is inactive, we don't want to show those subcategories. So I'll go ahead and show you what's going on here. And this time we're doing a check for activity. And we'll go ahead and run this. So now we should only get categories that are active. In this case, all categories are active. So I need to make a change here in the table to deactivate some of these to show you what I mean. As soon as this query gets done running. Once again, that was effectively the same query we had before that took about 45 seconds. This one might take just a hair longer. 1, 2. Probably because we have this extra condition in here. Okay, 47 seconds. Okay, well, we just want to get the active categories. Right now, they're all active, so I'm going to go ahead and let's see. First, I want to select all these. Let's go ahead and do this. I want to make all categories under AA, category AA, we'll make those inactive. So just go ahead and do a quick equal 0 ID equals 2. Run that. There we go. see, make sure it's there. Okay, it's inactive. So any category under this category will not show up on the output. So let's go ahead and run this again. The common table expression query. And should be a little faster than it was, theoretically. Okay, we're at 25 seconds, 6. And it's taking its sweet time. Ah, there we go. Still running there, but now we see that there is category A. In fact, I'll have to just scroll down until it starts going to category A. And you can see category AA is not there under category A. Yeah, it just went straight to category AB here. And we can see the subcategories of category AB, but we don't see category AB, AA, category blah, blah, blah. It can get confusing. So that works. Now let's try this same query with the multiple joins. Here we go. Now it's starting to get squirrely here. So we'll go ahead and copy this, paste it in here. And now I've done something different here to speed things along. I think there is a better way to do this, but I could not quite figure out how to do this. So I created a temporary table, a table variable, and I put in all the categories that are not active into that table. Then I do the query as usual, and this time I do a test. If any of those IDs, any of them at any level, are in that inactive table, we return a 1. Else we return a 0. So if any of them are true, then 1 equals 0. That's not true, so those results will be ignored. So all these conditions have to be true, or any of these conditions can be true, and then it will ignore that particular row return. So let's go ahead and execute that. And we'll do a little time comparison. Now notice with the multi-join method, your results start showing up in this little results window sooner. And I'm not really sure why it does that. I think if somebody knows why this is, they could probably help explain that. Please leave a comment somewhere. Okay, now this one's still running. Getting all the active categories that don't have a parent category that is inactive. And this one seems to be taking a bit longer. Maybe a lot longer. 1959551. 1959551. They should have the exact same results, and they do. Now this one was 46 seconds. This one was 55 seconds. Probably the slowdown is right here in this case statement. Okay, we move along. Let's go to the next level here. Now here's another query we can run real quick. This is active categories starting at a particular branch. And this one is pretty self-explanatory, I hope. And once again, I have little sections here that I commented out whether you want to include the parent or not include the parent. An interesting thing here is that if I say don't include, oh wait a minute, oh okay, never mind, we're good. So this one took 11 seconds. Very good. I will go ahead and do the equivalent, which really gets goes up here. And the multi-join method. The only difference here is besides having this case statement here, we also need to check if the branch ID is there in the aliases, aliased IDs. And so I'll go ahead and run this. I believe I'm starting from the same branch. Well, that's running. I'm going to tab over. Yeah, same branch. Okay. So we have 335, 923. This should work. We should get the same number of rows. And once again, it started displaying the results. Okay, 21 seconds. Well, that's interesting. Once again, the CTE has outdone the other one. And your results may vary. I've actually had this query run faster than this query on SQL 2014, running on a separate machine, the enterprise version. So you get the idea. Okay. Now let's go to depth. And sometimes you need to know the depth of your tree or branch. So I will go ahead and copy this. This once again, CTE, paste it in here. Go ahead and run. Now this time we've added an extra header or whatever you call it, field, column, depth. And then we add one to it, depending on where you are. And well, let me just run it. Let me see if I use the same branch. Yes, I did. Okay, we're going to go ahead and run this so we can do a fair comparison. So now I'm returning only the active ones as before, starting from a certain branch. And this time I get the depth. So I'm getting the level of these categories. And notice all these are depth. Notice this is also depth of 0, which I might have to take a look at that. Seems to be starting at a different spot. Interesting. And then it works from there on out. May have to check on what I did here. Maybe take out the parent. Ah, I see what happened here. If you include the parent, it doesn't really know what to do with that based on this condition. So you might want to keep track of that. So in this case, we're starting from a branch that is not at the rudimentary, the most fundamental depth. So it's going to start its depth counting at wherever you start. Maybe we can work on something that later. So okay, that looks good. Let's try another one here. Let's do see how we do depth with a join query. Okay. And then we'll compare the speed. In fact, did I run that? 11 seconds without the parent. Let me run this the same way. Okay, we want to exclude that and then pop this in this way. Okay. Different concept, but now the depth is determined up here. This is one way to do it. And it's just returning the depth of the particular level that we are in. Basically hard-coded. And this is an alternative method, which I'll cover here real quick. This. Let's see how it compares. Okie dokie. Okay, we're starting to get some results here. I'll scroll all the way down. It looks like I need to change my query so my depth is better reflecting of what's going on here. So actually, I'm going to check the other query real quick. I'll take this, comment that out, comment this. This basically adds, if the ID is null, it adds everything with an IIF function. I'm not sure if this works with every version of SQL, but this is another way to do it. And we'll see what's going on here. I think I know what's going on here. Now this is showing me the true depth. Since I started with a later category, a second level category, or branch, this is giving me the true depth. So this is depth, this is actually depth level 1. I think I did that on purpose. It's been a while since I wrote that query. Let's compare the times. We got 20 seconds for that. 11 seconds. Once again, the CTE is beating it. I'm not really sure how this happened, because this is really depth of 1. Maybe I need to start with 1. I'll have to figure this one out. And then add 1 to that. So it looks like I need to figure out the depth of that particular branch so I can accurately return the depth here. Yeah. Now that should look the same. Of course, this one I didn't put an active. It's not there. I can go ahead and add that there. What? And this will show you what's active. When I said before, it's always going to look at the first piece. Well, let's just go ahead and run that. Well, better to see how it works. Yeah, we know it took 20 seconds last time, so probably about 20 seconds this time. Okay. Yeah, 20 seconds, 335922. Lost my mouse there, 335922. Okay, so we're good here. All right. Well, that's about it. I will put all the source code and all these queries in the links below, and a link to GitHub so you can download the source code for the DB stuffer program, which stuffs this category with all the different subcats, etc., etc. And then you can practice on your own. That wraps it up for this video. If you like this video, please click the like button below. Feel free to comment below and be sure to click subscribe for more videos. Be sure to check out the provided links for source code and reference materials, and check out my sponsored links below. Thank you.